Well, here we are at Turner, Montana, a couple miles from the Canadian border in north central Montana, on the highest terrain in the area called the Flaxville Planation Surface. And here we have a large erratic boulder from the Ice Age. Now this erratic boulder is nice, kind of like a banded granite. This type of rock does not outcrop anywhere close to here, hundreds of miles. The nearest source is the Canadian Shield to the north, about 400 miles. You'll find them in farmers' fields piled up by the hundreds. This erratic was from the continental ice sheet, whose boundary was to the south, about 40 miles from here. The continental ice sheet extended over central and eastern Canada and the northeast and north central United States. The question is, how did they all get here? Did the ice move them from the Canadian Shield slowly? There's a slight problem with that, because when you look at how thick the ice was in this area, it was actually very thin. The Flaxville Plateau further to the east was sticking above the ice, and to the north we have the Wood Mountain Plateau in Saskatchewan that was unglaciated, so it's called a driftless area. Well, the boundary of the ice was 40 miles to the south, and we know to the west it was thin too, because the western end of the Cypress Hills stuck up 300 feet above the ice. So the ice was only about 700 feet thick, about 100 miles north into Canada. So essentially the surface, it was thin and flat. For a glacier to move, it moves by its surface slope slowly. And if it slopes down to the south, it should move from the north to the south. But if there isn't any slope, there's a problem of it moving. Then how did this erratic get here if the ice was too thin to move it? When you have ice, it's got to melt. And during the melting phase of the ice, you have all kinds of glacial rivers and glacial lakes, and you have icebergs with rocks in it. So I postulate that this and all the tens of thousands of erratic boulders like this came down in icebergs and by water action as the ice was melting. In fact, you can see something of the action of water. This is what's called sub-rounded. Looks like water's been affecting this. And most of the erratics I've seen are either rounded or sub-rounded. Some of them they're huge and or small. So I think the glacial fluvial, as they call it, the action of big, huge floods from the ice and lakes at the edge of the ice sheet, moved these erratics from where they eroded from the bedrock to where we see them here today.